Today I will discuss the isobaric process. In isobaric process, the change of the pressure of a system remains constant, or we can say the pressure remains same or constant. So in a reaction, the pressure remains always same. The delta P equals to 0. The reaction is ongoing from starting point to ending point, but the pressure remains same in overall process. That is called isobaric process. Okay. P here is denoted as the pressure of the system. The vaporization of a liquid in an open system at constant pressure, it is a isobaric process. এটা হচ্ছে isobaric process এ isothermal process. So here it is an example, the vaporization of a liquid in a open system. In a open system, the liquid is vaporizing in a pot. I have taken some amount of water and I am vaporizing it. But you will see the pressure is remains P is equal to 1 atmosphere. Okay. In overall reaction, the time is taken to becoming the water to vapor. The pressure remains always same 1 atmosphere. So it is a isobaric process. Isothermal process, in a process the temperature remains same during the reaction or change of the system occurs. In a system, a reaction is occurring, okay, but the temperature remains always same. If you think that temperature was T is equal to 0 at the starting of reaction, but the temperature T becomes 100 degrees Celsius at the end of temperature, no, that is not possible in a isothermal process. The system changes, the materials changes in a system in a reaction, but temperature remains same. Okay, so delta T is equal to 0. So T remains same at every one. T temperature remains the same at every step. T equals to here denoted as temperature. So here is an example. The water is boiling at 100 degrees Celsius temperature and 1 atmosphere pressure. The pressure remains the constant and also the temperature remains constant in overall process. Here the pressure I have written and also the, which is the isothermal, so also temperature. The water of 100 degrees Celsius becomes the steam of 100 degrees Celsius also. Okay, so temperature of the water and also the steam is same 100 degrees Celsius. Isochoric process. The volume remains same in a process. It is called the isochoric process. The volume remains same in overall reaction. So then the process is called isochoric process. Here delta V equals to 0. V here denoted as the volume. Like combustion of any material in a bomb calorimeter. In a bomb calorimeter, I have taken some substance and I am heating it to make it a vapor. So if the vaporization process is occurring, but the volume of the substance remains same. Okay. If I have taken the substance of 1 gram, then it will be a substance or the vapor of 1 gram also. So the volume same, so it is the isochoric process. Here I have drawn 3 graphs of the 3 type of process I have studied. Here it is the pressure and volume. It is a curve at constant temperature. It occurring at constant temperature, it is a curve. At constant pressure, at constant volume, constant pressure is constant, the volume is increasing. Okay, and here the constant volume, pressure is increasing but volume is constant. Temperature constant but the volume is decreasing here. At constant pressure, pressure is constant here, so that here pressure is constant at a particular point, but the volume is increasing like 1 2 3 4 in a process, and here volume is constant. With increasing the pressure, reaction is occurring but volume remains same. Okay, Now I will discuss the adiabatic process. In the adiabatic process, the exchange of heat from system to surrounding does not occur. In a system, here is a system in a box, and here is the surrounding, our environment. Okay, so here the system is changing, like suppose system is taking water or system is taking steam from the outside surrounding. System is also giving some steam, some vapor to the surrounding, but the exchange of temperature will not occur here. That is denoted by the Q. Exchange of heat between the system and surrounding does not occur. Okay, so it is the adiabatic process. Now I will discuss a reversible process. The process can go forward direction and also in the backward direction. A process like I am heating a water, it will produce a vapor. If I cool the vapor, then again it will transform to the water. So it is a reversible process. Okay. First I have taken a box and here is a gas. The gas may be oxygen, chlorine, hydrogen, etc. Anywhere. So anyway, so here is a piston I have taken in this box. At first I have increased the pressure on the piston. I am pressing the piston and increasing the pressure P. The pressure is increased at the dP amount continuously and the volume also decreases in dV amount. So I am increasing the pressure at dP. dP amount pressure is increasing on the piston and the volume. The piston is going towards the pot or going towards the vessel, and the gas is also, the volume is decreasing of the gas. Okay, so I am increasing the pressure of the dP amount and volume is also decreases. Next, if we decrease the pressure, if I again pull the piston, then the dP amount pressure will also decrease, but volume will also increase in dV amount. Okay, so we can get the same amount, same of the volume amount of the gas again. At first the volume of gas was V. We increase the pressure on the piston and the volume decreases dV amount. Next, we again pull the piston from his before the position. We pull the piston and the volume get increased. The volume increases at a dV amount. Okay, so it is a reversible process. Volume is at first decreasing and again the volume is increasing. It is a reversible process. Now I will discuss the irreversible process. There is a gas in a cylinder. A piston is on it. A piston is on it, the cylinder gas. Okay, the pressure is increased on the piston P. On the piston P, the pressure is increased on the piston P. The volume decreases. If somehow P increases from P to P prime, at first we are pressing the piston in the cylinder and the volume was decreasing. Now if somehow the pressure increases from P to P prime, the volume of the gas will decrease. That at first I increase the pressure by pressing the piston inward of the cylinder, and again I pull the piston and pressure decreases and volume will increase. Somehow pressure decreases. The temperature of the system and surrounding was same at first. At first, when the reaction does not started, when I did not increase the pressure, the temperature of the system and surrounding was same. When the volume increases, the temperature of the system will also increase. If we increase the volume of the system, then the temperature will also increase. So the temperature does not remain same through the process. Temperature does not remain same through the process. It is a irreversible process. Why is temperature increasing? The some amount of gas I have taken in the cylinder, and here there are the molecules of the particles of the gases. If I increase the pressure, the randomly they will go here and there. The particles will go randomly here and there in a cylinder. So the internal energy will increase. Okay. So then you can see that the temperature will exchange from system to surrounding. If the temperature of a system internally increases, then it will also exchange its temperature with surrounding. So it is a irreversible process. Okay. Here is another types of examples of irreversible process. The water flows from upward in a mountain towards downward. In a mountain, let's see, water is flowing from upward to downward. Okay. So it is reversely cannot go from downward to upward. Reversely it cannot go downward to upward. Water always flows upwards to downwards. Okay. So it is a irreversible process. Like this, here the increase in the temperature is also a irreversible process.